Hi class, we continue our study in chapter 6 talking about quadrilaterals by now moving into section 6.4. And section 6.4 is about rhombuses, rectangles, and squares. So we have three objectives in this section. First is we want to define and classify special types of parallelograms. We want to use properties of diagonals of rhombuses, rectangles, and squares. And then the third thing is we want to use properties of diagonals to form rhombuses, rectangles, and squares. All right, so a few special parallelograms. So a rhombus is a parallelogram with four congruent sides. So it'd look like this, right? All the sides are the same length. A rectangle is a parallelogram with four right angles. So it would look like this. But notice we don't say anything about congruency among the sides. And a square is a parallelogram with four congruent sides and four right angles like this. All right, so in this section, we want to just study these three types of special parallelograms. Excuse me. All right, so over here, what I want to do is use properties of special parallelograms. So I'm telling you here the figure shown is a rhombus. So I want to do two things. I want to find the value of x, and then I want to find the measure of each side. Well, the sides of a rhombus are all congruent, so it must be that this side AD is equal to this side BC. All right, or plugging in that 5x minus 7 is equal to 3x plus 5. So you just have to solve this. So you're going to subtract the 3x over and add 7 to both sides, like so. And then in the final step here, you're just going to divide by 2, and you're going to get x is equal to 6. That's great. So for the second part now, you want to find the measure of each angle, or measure of each side, excuse me. Well, AD is equal to 5x minus 7. Plugging in 6, I get that it's equal to 23 millimeters. Now, DC should also equal 23 millimeters also, all right, because they're congruent sides, but let's check. If I have DC here, which is 3x plus 5, I plug in 6, yeah, that does become 23 millimeters, so it works out. So remember, rhombuses have congruent sides. They're all the same measure. So we see here that all the sides here are those 23, like I just said. All right, to help you kind of visualize this, I have a Venn diagram here. All right, so quadrilaterals encompass all polygons with four sides. Within the quadrilateral, you have parallelograms, okay, which has two sides, two pairs of parallel lines. All right, so parallelograms are quadrilaterals. Now, rectangles, squares, and rhombuses are all parallelograms. But rectangles that have four right angles are also a square, right? Because a square also has four right angles. Now, a rhombus is also a square as well, but it's not a rectangle. A rhombus has four congruent sides, while a square has four congruent sides. And then all of these things are all quadrilaterals, which are all parallelograms. All right, so a quadrilateral up here is a parallelogram. So there's a lot of polygons with four sides, but what makes a quadrilateral a parallelogram is their opposite sides are congruent, their opposite angles are congruent, consecutive angles are supplementary, and its diagonals bisect each other. If you have those things, it guarantees you're a parallelogram. All right, let's identify each parallelogram as a rhombus, a rectangle, or a square, and be precise as possible. Well, here, what I'm able to say for A is a rectangle. All right, this is because this is a parallelogram. We know that all four angles are right angles. Great. Since the sides are not all congruent, this is not a square nor a rhombus. Right? You can tell that this side is not congruent with this side. B, what does this look like? Well, this obviously looks like a square. All four sides are congruent, and all four angles are right angles. And then over here we have four sides congruent, all right, but not the angles are the same. So C is a rhombus. So all four sides are congruent, and the angles are not given as right angles. So that's not good. All right, it's got a bunch of theorems now. All right, theorem 6.4-1. This is the rhombus diagonal perpendicular theorem. So a parallelogram is a rhombus if and only if its diagonals are perpendicular. So the parallelogram ABCD is a rhombus if and only if AC is perpendicular here to BD. So that means when they're perpendicular, they form a 90-degree angles where they cross. Another theorem, right? This is rhombus diagonals. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Right? So what that means then, if it bisects a pair of opposite angles, this diagonal, when it crosses it, parallelogram ABC is a rhombus if and only if how it bisects the angles. Angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, angle 5 is congruent to angle 6, and angle 7 is congruent to angle 8. All right, so these angle pairs here are congruent. They have the same measure because the diagonals bisect. All right, and that'll guarantee that it's a rhombus. Finally, a parallelogram is a rectangle if and only if its diagonals are congruent. So parallelogram here, ABCD, is a rectangle if and only if the diagonal AC is congruent to the diagonal BD, just like that. All right, so here's a problem. In rectangles, so I'm telling you it's a rectangle RSBF. SF is equal to 2x plus 15, and RB is equal to 5x minus 15. What is the length of this rectangle, of this diagonal here? Well, we know that diagonals of rectangles are congruent, so their lengths must be equal. So what we can then do is it must be that SF is equal to RB, or 2x plus 15 is equal to 5x minus 12, and you just have to solve for x here. So subtract the 2x over, now add the 12 over. Now you have 27 is equal to 3x. Divide both sides by 3, and you get x is equal to 9. All right, but that's not the answer. All right, remember I asked you the length of the diagonal. So to find the length of the diagonal, choose one diagonal expression and substitute 9 in for x. So it doesn't matter which one you pick, you'll get the same answer, but I'll take 5x minus 12, I'll plug 9 in, and I'll get that the diagonal is equal to 33. All right, let's do another one. So I'm telling you this, what are the measures of the numbered angles, 1, 3, 4, and 2 here, right, in rhombus? So I'm telling you it's a rhombus, A, B, C, D. All right, well, first off, what I can see here is the measure of angle 1, because it's a rhombus, this has to be a 90-degree angle. The measure of angle 2 has to be the same as this angle because they're alternating interior angles, all right? So what that also must mean then is that angle 3 is also 58 degrees, because remember, it bisects it in such a way that the opposite angles right here are equal to each other. Well, so I know angle 1, I know angle 3, I got angle 2, I just got to find angle 4 here now. Well, I notice here that I have a triangle. So the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 has to be 180 degrees. Substituting in what I know from measure of angle 1 and measure of angle 3. Combine them, subtract it over, and the measure of angle 4 then has to be 32 degrees. So I've got all the measures of the angles here that I was looking for. Just by knowing that it's a rhombus, alternating interior, they just have to be the same too. 90-degree angle here, and they sum up to 180 degrees because it's a triangle. All right, for what value of x is this parallelogram ABCD a rhombus? All right, so for what value of x here will make this a rhombus? Well, to be a rhombus, its diagonal must bisect a pair of opposite angles. So it must be then that these two angles are equal. So angle ABD is equal to CBD. So just set these two equal to each other, like so, and then just use a little algebra to solve for x. So subtract the 4x over, add the 2 over, finally divide by 2, and you get x is equal to 5. So if x is equal to 5, then this guy here, this figure here, is a rhombus.